So in this section, I'm going to talk to you about writing better formulas. So we can actually write better formulas, and we can do that by sort of thinking about the formula problem. So we can design for readability. That means that the way that we design things, as I showed you in the demo, to make it easily readable for us later. Second, we can use formulas that are a natural fit to the underlying problem. So I commonly talk about this when I speak, but whatever we produce should be the natural extension of the underlying problem, and formulas as being part of that can become a natural fit. And you'll see what I'm talking about here in a minute. And finally, we can think about all those ifs we use. Clearly, we're not going to get away from using an if, but if we have to use nested ifs, and following this idea of natural fit, we should actually only use nested ifs when they fit the problem, and that's often in cases when we can draw a decision tree. So what does it mean to design for readability? Well, going back to our demo, you can see this top formula, which is fairly complicated. Now, if I use Alt-Enter, I can move those functions to another line. So actually, you see here that we have multiple ifs, 3 ifs. And you can see by moving it to the next line and using indentation with the space key, I've actually made this function a lot easier to read. Next, we can use named ranges, and we can use them as much as possible. So sometimes we have a list of items and it's not useful to use a named range, but as we're developing, it's usually a good idea to use one if we're only going to refer to one cell. So if we don't have a whole range where we're dragging a formula down, if we have one cell, and you'll see there are cases in which we develop that will make the most sense. So cell names should always reflect what you're trying to test. In this case, we see I've named it the droids you're looking for, which hopefully some Star Wars fans will understand what's going on. But if you are a Star Wars fan, or even if not, it's very clear what we're testing. Are these the droids we're looking for? If that equals true or if that equals false. Compare that to using cells in numbers where it's not clear. We know that an if is happening. We know some condition is happening, but there's no way for us to understand what's going on caked into the formula itself. So that's what I'm trying to do. So let's take that uncertainty surrounding formulas and make them slightly more certain. Again, this isn't going to solve all your problems, but it will actually make your life a lot easier when you have to give this to someone and explain to them what you did, or when you have to look at it 6 months from now and you think, what did I do? And this is a way of remembering what you did without actually going through pages and pages of documentation. So this is a really good way of putting documentation directly into your work. So keep that in mind. Okay, so I talked to you about natural formulas. And this image you see here is one from Microsoft's help. So this came from their help. And it's from their article about nested ifs, which is sort of problematic for me, as you'll come to see. But here is how they've set it up. You have a score. So a student received a 45, a 90, or a 78. And the formula here that is trying to see what letter grade to assign these scores. So you can see this is a classic nested if, right? We test if the value is greater than 89, return an A. If it's not, we're going to put a nested condition in here. So if it's greater than 79, return a B. If not, if it's greater than 69, return a C. If not, return a D. And if it doesn't satisfy any of those conditions, return an F. And you can see that this is happening across all of these scores. Now, the question is this type of problem where we're trying to assign a letter grade to a student, is this a good problem for nested ifs? I would argue that it is not a good problem. And if we think about what this problem is trying to do, it would be what I describe as a lookup problem. And when you have lookup problems, you should be using lookup functions like index and match. So why do I think that this is a lookup problem? Well, if we think of this in terms of the data, so it's always a good idea to go back to the data. The reason that you get a B is not because you did not get an A. Sure, you didn't get an A, so the next thing in line is getting a B. But let's just think about this slightly more. If I get a D, it is because my number falls. My average grade score falls between a range of 60 to 69. That's why I got a D. It's not because I didn't get a C, and it's certainly not because I didn't get an F. So when we're thinking of conditional or branching conditions, which is the case of a nested if, we have to think about what that means. Is the reason we got something because we didn't get something before? That's what a nested if is saying. But here, this is not a good problem for a nested if. And in fact, it more naturally reflects a lookup problem. And you can see this here. I have an input cell. I match that location. So I say 50. I do an approximate match function, and that says it's in the location of 5, which I can look that back up with an index, becomes an F. So I guess I didn't do very well. The point is that this problem is better described as a lookup problem. So yes, if can work here, but in many ways that's just looking at the world through the eyes of a hammer where everything's a nail. If we want to remember what we did, the underlying problem should closely align to the functions we use. Here again is another great example. So I have a set of product IDs, 1, 2, 3, and I have a set of sizes that are related to them, small, medium, and large. So let's say I want to figure out, based off the product ID, which item size I'm referring to. So again, using the eyes of a hammer approach, if we use only an if here, we see that we have kind of this slightly complicated nested if. Now, nothing in this actually really follows or organically follows the problem. So if I look at C7, I look at this if problem, we can take a look and we see that there's nested conditions here, but nothing here really organically follows the problem. It's not entirely clear what I'm trying to do based off of this function. Now let's compare that to choose. Choose is one of my favorite functions, and we'll actually see it in action later in this course. But you can understand choose as picking from the index you provided. So we have small, medium, and large here. If I want this to return a small, B6 would have to be 1. If I wanted to return a medium, B6 would have to be a 2. For a large, B6 would have to be 3. I can actually add on as many quotes as I want, I think up to 255. So whatever I want to return needs to be given by the index of that first parameter of choose, which I've selected here as B6. So you can see how this closely aligns, small, medium, and large. So the data here is ordinal. So you see small, medium, large, it goes in its natural order. And if you're new to sort of data thinking, ordinal means that even though these values are not numerical, they actually have some sort of inherent numerical order. So again, there is some sort of natural piece to this problem that is lost when we use ifs. But if we use choose, it makes sense, 1, 2, or 3. So then you might be wondering, when should someone use nested ifs? When is there a case when there's a branching compounding condition, as I would call it? Well, in this case, I've set up an if formula, which is testing for project status. So if the project status has stopped, it will test the error code. And then from there, it will figure out why the project had a problem, or if the project hasn't stopped, it will return project as finished. So here we actually have a branching compound condition. How do we know? Because we can easily draw a flowchart from it. And you can see that flowchart on the right. It makes intuitive sense. It feels intuitively pleasing, as my accounting professor used to say. And when you feel that way, you know that you've probably done something correct. So if you can draw a flowchart, as I've done over here, chances are that the nested ifs that you're using are correct, that it's a good idea. So another way of thinking about it is always to start from the end, or start from an internal endpoint. So let's see here, halted by internal error. Why would it say that? Well, it could only say that if the error code didn't equal 1. And the only way that it could test the error code is if it had stopped. So if you're able to back up, then yes, you have a decision problem that could require nested ifs. So it's not a lookup problem, and it's not just testing things on an ordinal scale. So if we think about using nested ifs, and we can just elaborate on this a little bit more. We only want to use them when the problem naturally lends itself to a set of branching conditions. And if you can turn the problem into a flowchart, chances are it's a good idea to use it. And finally, if we can start from an endpoint and we ask, does this result naturally follow from satisfying the previous conditions or not satisfying the previous conditions, then yeah, we're probably in good shape to use nested ifs. Here's when we should not use them. We shouldn't use them haphazardly. Don't use them as a hammer where everything is a nail. Don't try to brute force things. As a general rule, I don't use more than 3 nested ifs because I find that beyond 3, it actually gets hard to understand what's going on. And I didn't just make that up myself. We know from our working memory that we can hold 3 to 7 chunks at any time, and a lot of that is dependent upon the size and complexity of those chunks. And if we're talking about nested ifs, they're generally large and complex. So using more than 3, it's going to be kind of hard to think about, just scientifically. So that's why I like to use less than 3, and your mileage may vary on that, but try to keep a rule in your mind so that they don't get unwieldy. And finally, don't write ifs in such a way that only you can understand. So let's say you're not really sure if it's a branching compounding condition, and you're really short on time, and you're saying, whatever, I'm going to use ifs anyway. Well, at least help yourself out by using things like named ranges, using space, using them in ways that reflect the underlying problem that you're trying to test, so that when you come back later or when someone else looks at your work, they understand what's going on, and so that you've put what's going on into your work. You've documented it using these tools and techniques.